Hi everyone. So let's talk about writing a quadratic function from a quadratic sequence. So we have the sequence 1, 5, 13, 25, and 41. And each of these terms, they each has a label U1, U2, U3, U4, U5, and of course, all the terms after 41 would be U of n. That can also be called the nth term. And we are particularly using these labels here because we're going to be using a lot of variables to write the quadratic formula in this case. But anyways, you could also call this or say it as u of 1, u of 2, u of 3, and so on. And you could always also call this u1, u2, or u3. And let us take a look at how you find out if this is really a quadratic sequence. From previous discussion, we said that once you find out that the second difference are all the same, then you say that the sequence has a quadratic relationship. So ignore those red labels there for later. We'll use those labels for later. But anyway, so the first difference here have 4, 8, 12, and 16 for its terms. And the second difference finally got us all the same with a value of 4. And after you've determined that to be quadratic, you can actually use a general formula that says u of n equals an squared plus b times n plus c. And later on, let me just point it out early in this video that this can be turned into the standard form of the quadratic function or a quadratic equation. So we simply would replace the u of n with the y and all the n with x. And the coefficients a and b and the constant c are the values we're going to solve for. So we also have all these relationships that are already laid out for us, so we can easily find a, b, and c. And this relationships says, the first one says 2a is equals to the second difference, and so we could simply say 2a is equals to the second difference is 4. So we're going to have that at the bottom um, in more details. And the other relationship, the second one is 3a plus b would use u of 2 minus u of 1. That would be 5 minus 1, and that is actually 4. So 3a plus b, which is u2 minus u1, is also equals to 4 in this case. And a plus b plus c is equals to u of 1, which has u of 1 equals to 1. So we could simply write this down as 1 here. Now, I've already prepared the solutions just so that we don't have a very long video here. So as I mentioned before, here 2a is equals to 4 because it's the second difference. Let's say that's our first equation. If we have 3a plus b equals to u2 minus u1, then we would also use 4 here. u2 minus u1 is equals to 4, so we could write this as 4. And a plus b plus c is equals to 1. That is your first term. And here it is. So if you simplify those equations, and I'm going to make this a little bit bigger. If you simplify all those three equations, we actually have a system wherein if you solve the first equation, you're going to have 2a equals 4, dividing both sides by 2, because we have 2 here as a coefficient of a. You end up with a equals to 2. So you can already use that value for your second equation, 3a plus b equals 4. And substituting 2 for your a, you have now 3 times 2 plus b equals 4. And 3 times 2 is 6 plus b equals 4. And then we subtract 6 from both sides of the equation. And canceling those 6 there will give us b equals 2, negative 2. 4 minus 6 is negative 2. And then again, using the values of a and b into your third equation, a plus b plus c equals 1, substituting 2 for a and negative 2 for b, we just have c as the remaining variable once we cancel out 2 and minus 2 here. So it's going to leave us c equals 1. And of course, after we find all of the values for a, b, and c, we substitute it back into our general formula. And so we're going to end up having, so substituting that and simplifying, I just substituted 2 for a, negative 2 for b, and 1 for c. I end up having u of n equals 2n squared minus 2n plus 1. And again, a reminder that this is the same as the standard form for the quadratic equation, y equals ax squared plus bx plus c, or you also can write it in function notation, f of x equals x squared plus bx plus c. So you can also, again, you can also have that y equals 2x squared minus 2x plus 1 once you change all the n's into x and you change your u of n into y. You could also write here of f of x, and that would mean the same thing in this case. If you have any questions, I will entertain all those questions during our discussion. Thank you for watching.